antagonist is one of two marine fungal-derived antagonists. This one had one rotatable bond, only gave us one conformation, really easy. I wish all my antagonists were like this. But we can see that final conformation there on the right in green, and we rotated about this bond. So when antagonist 2 was docked in the inactive bundle, we see that we're still seeing an interaction with that primary interaction site of arginine 542. It's interacting with those electrons on that pi that conjugated the aromatic ring and creating another cation interaction. What we're also seeing now is a new interaction. We're seeing a hydrogen bond forming from the tyrosine 160 on the top of helix 4 with that hydroxyl group on our antagonist. Now, like I said, this is one of two of the marine fungal derived antagonists. This one had a better IC50 value, and we also got a better glide score with this one. With its partner, we saw a lower IC50, not a lower, a worse IC50 value, a higher IC50 value, and we're seeing also a higher glide score. So it's really good that we're seeing this correlation of their IC50 values reflecting that glide score. So and like I said, this one got a glide score of negative 6.73. So with the other marine fungal antagonist, we're seeing a lot more rotatable bonds. It's 4 this time, and it gave us 83 conformations. And it was rotated about these bonds here. Now, all 83 of those conformations were docked in the inactive bundle, and the best glide score we got showed a hydrogen bond interaction with that primary arginine 542. Like I said, you see a pattern here. And that was able to generate a glide score of negative 6.2, which is lower than the other marine which is higher than the other marine fungal glide score, which makes sense because it also got a higher IC50 value. So we think that we're getting a good idea of the interactions that are going on in this bundle. Now, one of the most impressive antagonists that I got to dock was this antagonist 4. It's a synthetic antagonist, and it got a really impressive IC50 value. So we were really curious to see what it was doing in the bundle that was perhaps giving it such a low IC50 value. It had 3 rotatable bonds, which correlated to 25 conformations, all rotating about these bonds here. When antagonist 4 was docked in the inactive bundle, we saw 3 interactions this time. We see our primary interaction with our aromatic ring, and the central aromatic ring in antagonist 4, creating a cation pi again with that primary interaction site. We're also seeing a pi stacking interaction for the first time with phenylalanine 546. And then again, we're seeing that tyrosine 160 coming in and adding into those interactions at the top of helix 4, creating a hydrogen bond again with the carbonyl group on the top of the antagonist 4. So this gave us a really impressive glide score, which I was not surprised because it had such a really good IC50 value. And it gave a glide score of negative 8.45. Our last antagonist that we docked, antagonist 5, is also known as cannabidiol. I'm sure a lot of you have heard of it. It had 3 rotatable bonds, and we were able to generate 8 conformations. And they were rotated about these bonds here. Antagonist 5 docked into the inactive bundle. We're seeing 1 interaction, and that's right at that primary interaction site. All of these antagonists, when they were docked in the bundle, were right on that primary interaction site, putting them right on top of that toggle switch, preventing that toggle switch from being activated. So, and that's ultimately preventing that receptor from being activated. So, we were really impressed with the results here, but the glide score ended up being negative 6.29. And then I have a quick table that kind of summarizes their glide scores, the conformational energies of the conformations of the best glide dogs, and then their IC50 values. So the agonist we then were going to use to dock into our newly modified activated bundle. NA glide had way too many rotatable bonds for us to be able to use this in Spartan. So we needed to use a program that was good at taking highly flexible molecules and finding conformations in a lot easier steps. That's why we have conformational memory method. So CM method was used to generate a set of low free energy conformations. Again, our ligand went through an exploratory phase and a bias phase. We were able to get 105 NA glide conformations, which I was very appreciative of because I'd rather go through 105 than 10,000. All these conformations were grouped based on their cis-double bond dihedral patterns, which I'll talk about here in a moment. And they followed the same trend as the CB1 endogenous ligand anandamide that was also ran through conformational memories and was given similar results. So what we see is in the output of our conformational memories, we're seeing this antagonist adopting 4 different shapes. And these are all based on the dihedral patterns that I'll explain here in a moment. But the 4 shapes that we saw were extended, J-shape, helical, and U-shape. Now, when I'm talking about the omega angles, and each omega angle contains 4 carbons. So for example, omega 5 contains carbons 5 through 8, and it's all going to be rotating about, I don't know if you guys can see my mouse, about this angle here. So I have a better picture that's going to show it. Oops. Okay, so here are the 6 different dihedrals that we focused on that were what were able to give the shapes of these different conformations. And for example, I'm not going to talk about all these, but I'll just give you an example of one of them. The U shape, what we're seeing for the pattern of that is when omega 6, that should be omega 5. Okay, so when we're seeing omega 5 and 6 and 11 and 12, when we're seeing those dihedral angles have opposite signs, so 5 would be positive and 6 would be negative, and 11 would be positive and 12 would be negative. That's ultimately going to give us a U-shaped conformation. Okay, so for our NA glide conformations, we saw that the highly populated shapes were both the helical and the U-shape, while we had very low populations in the extended and the J-shape. And we docked all 105 of these into the active bundle, and we saw that the one that had the best glide score was a U-shape. So we docked NA glide, and we got something interesting. We saw that NA glide is no longer activating with that primary interaction site that the antagonists were. Instead, it has a primary interaction site across the bundle at arginine 260. That head group of NA glide is forming 2 hydrogen bonds with that arginine. And what we're also seeing is that important residue that we were talking about in this the modular methods of pointing down into the bundle. That positive lysine is forming a hydrogen bond with the carbonyl group on the NA glide, and we're getting another interaction. That's keeping that ligand in that location, giving it a glide score of negative 8.14. But more importantly, what it's doing is that binding site is permitting that toggle switch to activate. So what you're looking at here is our 2 toggle switches, phenylalanine 648 and histidine 652, already in their activated trans state. So we're already seeing a bundle that's been activated. So in conclusion, I built a homology model of the active state of GPR18. Complete conformational analysis were conducted for all 5 antagonists using Spartan. The conformational analysis of any glide was found using conformational memories method, resulting in 4 clusters of shapes. The primary interaction site for all antagonists was the R542, and a secondary site for some of the antagonists was that tyrosine 160 on top of transmembrane helix 4. The primary interaction site for the agonist was arginine 260, and we also saw a secondary interaction site at that lysine on the EC2 loop. So there are now currently mutation studies in progress at our collaborator, Dr. Mary Booth's lab, that's going to test the importance of these interaction residues that were identified here to further our understanding of that GPR18 binding pocket. So in conclusion, I just wanted to give a special thanks to the UNCG Department of Chemistry and Biochemistry for allowing me to do my research. My advisor, Dr. Reggio, who's been incredibly supportive and motivating through these 2 years. And downwards, he was always my go-to man when I had technological problems. And Dr. Shore, who's no longer with us, he graduated and moved to New York with his PhD. And he helped me a lot with a lot of the methods of the different programs. And the Dr. Reggio lab in general. I was really fortunate to choose a lab like Dr. Reggio's lab. When you choose a lab, they really do become your family, and I'm going to miss all of them. So with that, I'll end my talk, and I can answer any questions.
Questions for Jennifer?